Hi students, this is Alex here. In this video, we are going to find the Fourier series expansion for the given function f of x, and also we are going to deduce the following. As a first part, I am going to check whether the function is even function or odd function. So first part of the function, I am going to take it as a g1 of x, which is 1 plus 2x by L. And the second part as g2 of x, which is 1 minus 2x by L. Now g1 of minus x becomes, when x is changed as minus x, it becomes 1 minus 2x by L, and we got g2 of x. That is, g1 of minus x becomes g2 of x. It means f of x is an even function. So f of x is an even function. It means the value of bn becomes 0. So we are going to find only a0 and an. So a0 by formula, it is 2 by L integral 0 to L f of x dx, and this is 2 by L integral 0 to L f of x is 0 to L. We have 1 minus 2x by L. So 1 minus 2x by L here into dx. Now this integration is L integration is Lx minus 2 by L is a constant, x integration is x square by 2, and we have the limit from 0 to L. We can cancel these two. By using the upper limit, we get L into L, L square minus, this is L square by, sorry, this is 1. So 1 integration is just x. So we have only L here. So this becomes L minus L square by L. After cancelling this, L minus L, which is 0. So we got an as 0. So let's write it clearly here. An is 0. Now coming to an, the formula is 2 by L integral 0 to L f of x into cos n pi x by L dx, and f of x is 1 minus 2x by L. So this becomes 2 by L integral 0 to L 1 minus 2x by L into cos n pi x by L dx. We are going to use Bernoulli's formula. The first part is u, second part is v. So u equal to 1 minus 2x by L. U dash becomes, this difference is minus 2 by L, and u double dash becomes 0. Similarly, v, we are going to take it as cos n pi x by L. v1 is, its integration is sin n pi x by L by n pi by L, and v2 is minus cos n pi x by L by n pi by L whole square. Now an becomes, we have 2 by L, and by formula it is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So limit is from 0 to L. Now using all these terms here, u is 1 minus 2x by L. U is 1 minus 2x by L, and v1 is sin n pi x by L, sin n pi x by L by n pi by L minus u dash, which is 2 by L. So we can put plus 2 by L, and v2, which is there's a minus sign. So minus cos n pi x by L minus cos n pi x by L by n pi by L whole square. So we have 0 to L as our limit. Now using the upper limit, when I put upper limit here, we get sin n pi after cancelling L and L, so it is entirely 0. When I put upper limit here, cos n pi, which is minus 1 whole power n. So we have minus 2 by L, then minus 1 whole power n by n square pi square by L square. I have taken minus, I have taken 2l and the denominator. When I put the lower limit 0, since this is a sine term, this will become 0. So minus of 0, and when I put 0 here, it will become 1, and there is a minus sign. So minus 2 into 1 by L into n square pi square by L square. Now finally, we have to simplify this further. 2 by L. Now we can take minus 2 and this L square and this L we can cancel, and L will go to the numerator. So 2L minus 1 whole power n by n square pi square, and here this will become plus 2 by, again we can cancel this and the L will go to the numerator, and denominator is n square pi square. We can take 2 by L into 2L common and denominator n square pi square also outside. After taking 2L, we left with minus of minus 1 whole power n plus 1. Let's rearrange this. We can cut these two. So this is 4 by n square pi square, and we can rewrite this as 1 minus of minus 1 whole power n. Now when n is 1, 3, 5 like this odd number, 1 minus of minus 1 power 3, what will happen? 1 minus, this becomes minus 1. So this becomes 1 plus 1, which is 2. So totally, this is 8 by n square pi square when n is odd. So this is the value of an. And when n is even, like what, 2, 4, 6, dot, 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 1 minus of minus 1 whole power 2, 1 minus of, this will become plus 1. So 1 minus 1, 0. So it is 0 when n is even. So we got the value of an. We are going to substitute this in the expansion formula. Let's write the expansion formula. F of x is a0 by 2 plus summation n is equal to 1 till infinity an cos n pi x by L plus summation n is equal to 1 to infinity bn sin n pi x by L. Anyway, bn is 0. Now a0 is also 0 here. So f of x, we have only one term, that is summation n is equal to 1 till infinity an, which is 8 by n square pi square cos n pi x by L. But this exists only for odd. So instead of n is equal to 1, we have to write n equal to odd. Now to convert from the odd to all the numbers of n, we can replace n as 2n minus 1. So the entire expression changes to f of x equal to summation n is equal to 1 to infinity 8 by 2n minus 1 whole square into pi square, then cos 2n minus 1 into pi x by L. So we can take the constants outside. The constants are 8 by pi square. After taking it outside, 8 by pi square, we have summation n equal to 1 to infinity and 1 by 2n minus 1 whole square into cos 2n minus 1 into pi x by L. This is the required Fourier series expansion. Now we also have the second part, that is we have to evaluate this 1 by 1 square plus 1 by 3 square plus 1 by 5 square equal to pi square by 8. So for this, let's take x as 0. So we get f of 0 equal to 8 by pi square summation n is equal to 1 to infinity 1 by 2n minus 1 whole square, and cos 0 is 1. And f of 0, from the function we see 0 here and here. When x is 0, I always get 1. So we are going to get f of 0 equal to 1. So using that, 1 equal to 8 by pi square summation 1 by 2n minus 1 whole square. This is from n is equal to 1 to infinity. So this we cross multiply. So pi square by 8 is summation n is equal to 1 to infinity 1 by 2n minus 1 whole square. When I take each value of n, that is when n is 1 here, 2 minus 1, 1. So 1 by 1 square I get. When n is 2 here, 2 to the 4, 4 minus 1, 3. So 1 by 3 square. When I take n as 3, 3 to the 6, 6 minus 1, 5. So 1 by 5 square plus dot dot dot. This value becomes pi square by 8. This is what we have to evaluate. 1 by 1 square plus 1 by 3 square plus 1 by 5 square equal to pi square by 8. So thus we got the second part of the proof in the given sum.